Objective 3. Define descriptive and inferential statistics. Descriptive statistics is the practice of using tables, graphs, and calculations about a sample to draw conclusions about only the sample. Inferential statistics is the practice of using information from a sample to draw conclusions about the entire population. In this example, a researcher tried to determine whether women who are more sexually confident about themselves are more likely to achieve sexual satisfaction. She arranged for 45 women to take a 112-question anonymous online survey. The researcher concluded that the more sexually confident a woman is about herself, the more likely she will achieve sexual satisfaction. Part A. What question were the researchers trying to answer? Well, highlighted in blue, whether women who are more sexually confident about themselves are more likely to achieve sexual satisfaction. Part B, identify the conclusion. Is it part of descriptive or inferential statistics, and then explain? Well, the more sexually confident a woman is about herself, the more likely. Now, is it part of a descriptive or inferential statistics? Well, it's inferential statistics since the conclusion is describing the population. Here's another example. An instructor wants to know whether the amount of sleep a person receives will affect their brain's thinking capabilities. To test this, she administered an exam to her students, and she also asked them to disclose the amount of sleep they received the night before. She concluded that for her students, the more sleep that they received, the better they performed on the exam. So again, what question were the researchers trying to answer? Well, highlighted in blue, whether the amount of sleep a person receives will affect their brain's thinking capabilities. And then we want to identify the conclusion. Well, the conclusion is that for her students, the more sleep that they received, the better they performed on the exam. And then we have to determine whether it's part of a descriptive or inferential statistics. And the answer is descriptive statistics, since the conclusion was only about her students. Now, a statistic is a numerical summary of a sample. We use the notation p hat, pronounced p hat, to stand for the sample proportion. A parameter is a numerical summary of a population. We use the notation p to stand for the population proportion. So going back to our figure that we had in a previous slide, we have our population and we take a sample from that. So a parameter would look like the following. A proportion, the parameter is equal to the proportion of population who are blue. Well, if you look here, we have 7 that are blue out of the total amount of people in this particular population, which is 20. So 7 out of 20 would then be 0.35. The statistic is p hat, which is a proportion of the sample who are blue. Well, how many are blue in the sample? It's 2 out of how many in the sample, which is 5. So 2 out of 5 is going to be 0.40. Now, an example, in a poll of 1,024 American adults, the proportion of respondents who said cloning animals is morally acceptable is 0.40, the source being Gallup. The study made a conclusion about all American adults. Number 1, we want to describe the statistic using words, a symbol, and a number if possible. Now, the sample consists of 1,024 respondents, so the statistic is the proportion of the respondents who said cloning animals is morally acceptable, which is 0.40. So, since we're dealing with a sample, we can say that the p hat is going to equal 0.40. Now we're going to describe the parameter using words, a symbol, and a number if possible. So the population consists of all American adults. So the parameter is a proportion of all American adults who say cloning animals is morally acceptable. We represent it by the symbol P. However, we do not know the value of P because the researchers did not poll all American adults.